In this video, I am going to explain the concepts in Unit 2, that is moving data and logical operations. In this unit, I am going to explain the introduction, addressing modes, external data modes, code memory, read-only data modes, push and pop-up codes, data exchanges, logical operations, byte level logical operations, bit level logical operations, rotate and swap operations. Let's start with the programming languages. There are three levels of programming languages: machine level language, assembly level language, and the high level language. Machine level language. It is the first generation programming language. The only language understood by the computer is the machine level language, which is written using binary codes, that is ones and zeros, and it is a fundamental language of the computer's processor, also called as low level language. Advantages: it is translation free and high speed. Disadvantages: it is difficult to learn, complex language, it is difficult for programming and writing, and it is machine dependent language. Let's see, this is a table of a code in machine level language to add two integers. So here we can see the left one as a hexadecimal notation and the right one as a code in machine level language, which we represent in the form of zeros and ones. Coming to the second language, we talk about assembly level language. The complete 8051 programming we write in assembly level language, where it is a second generation programming language, and it is a low level language that allows the users to write programs using alphanumeric mnemonic codes instead of numeric codes for the set of instructions. So this language requires a translator known as assembler to convert assembly level language into a machine level language. Coming to the advantages, it is easier to understand and use. It is easier to correct errors and modify the program instructions. Coming to the disadvantages, it is machine dependent language. It is harder to learn. So the machine level language and the assembly level languages are also called as low level languages. And it is a table or a code in assembly level language to add two integers. So the left column talks about code in assembly language and the right column talks about the description. So if you take an assembly language instructions, it is going to have a mnemonic followed with the operands. This we call it as an operands, and the instruction says that load from keyboard controller to register RF. Likewise, we'll be having certain instructions in the assembly language where it talks about the description. So this is a code in assembly language to add two integers. Coming to the third language is high level language. This language allows the users to write programs using a set of English alphabets and mathematical symbols. Here we require interpreters or the compilers that are used for converting these high level language into a machine level languages. Coming to the advantages, it is machine independent language and it is easier to learn. It is a small program for the addition of two numbers in C++. So we can say high level languages, the examples are C and C++, etc. Coming to the assembly language syntax now. 8051 assembly code syntax contains the following here. We'll be having a label, mnemonic, operands and commands. The items in the square brackets are optional here. Coming to the mnemonic. Mnemonic is the assembler instruction. For example, we have move is one of the mnemonic here, add, sub, CLR, clear, etc. Likewise, we have so many mnemonics here. So if you see this particular example, this is the label name, A10 is the label name, which is an optional, and this we call it as an opcode, and even we can call it as a mnemonic, or even we can call it as an operation code. This is a mnemonic. For example, we have taken as move, and this particular one is called as an operands. So here this is called as an operands, which has been divided into two parts. The first field is called as a destination field, and the second field we call it as a source field. So these operands have been divided into two fields. The first field is a destination field and the second field is a source field, and then this is the comment. Now this line talks about copy the immediate data 30H to the memory address location 81H. We are copying the data 30H to this particular address location. It means this particular line or this particular instruction. So let's see more in detail. The computer instruction consisting of two fields we already know. Mnemonic. Mnemonic is also called as opcode, and even it is also called as operational field. And the second field we call it as operand fields. So if you see the opcode field, this mnemonic, that is move for example, it specifies the operation to be performed on operands. So here this operands, again it specifies the data, which has been divided into two fields. The first field is called as a destination field and the second field is called as a source field. And one more very important here is the source field can be a data, or it can be a memory location address, or it can be a register name. Coming to the destination field, it can be only a memory location address or it can be a register name. So this is very important when you write the computer instructions. Already in the first unit we have studied about 8051 architecture. In that we have seen about the memories like RAM, ROM, etc. We have seen different types of registers. We have seen general purpose registers. We have seen special function registers. So whenever the CPU want to access the data, anything from the controller, then these are the following instructions we need to use. The instruction syntax says that we need to write start with the mnemonic and followed with the operands. This operands again divided into two fields. One is the destination field and the second one is source field, where the source field can be a data or it can be a memory location address or it can be register name. Register name means, for example, it can be A register, accumulator register, B register, PSW register. So whatever the registers we have studied in 8051, all the registers we can use it here. Okay, here or here. Remember that the source field specifies the data. It even specifies the memory location address and even it specifies the register names. Memory location address means what? Memory location address means we have studied about RAM, ROM, etc. If you see a RAM, we have lower 128 bytes RAM and upper 128 bytes RAM. So whenever CPU want to access anything from the memory locations, that memory location addresses we can specify over here and even we can specify over here. Okay, later on you will be very clear when we write about the instructions. Right now you remember that a computer instruction consisting of two things. One is the opcode and the operand. The opcode is nothing but a mnemonics, like we'll be studying about different mnemonics. And coming to the operand, it has been divided into two parts, destination field and the source field. So here the source field can be a data, it can be a memory location address or it can be a register name. Whereas the destination field can be a memory location address and it can be only a register name, which is very important. That I have mentioned in this here. Source field can be a data, memory location address or the register name. The destination field can be a memory location address or the register name. Coming to the next one, mnemonic. It is also called as opcode. It is also called as operation code. So when we talk about a program here, program is nothing but set of instructions. All computer work according to the program. All the instructions contain a verb which tells the computer what to do. This verb is called as a mnemonic or operational code. For example, we have taken move. This move is called as a mnemonic, or it is also called as an operational code, or it is also called as an opcode code, where it is moving the data. From where it is moving from here to here. So this first field we call it as a destination field and this field we call it as a source field. So this move talks about it is moving the data from the source field to the destination field. So here the source field we have written it as a data. So whenever we are writing a number here or a data, the data must be preceded by a hash sign. So whenever you have a hash symbol, this indicates that it is a data. So this particular line says that it is moving the data 12H to the register R0. We know that we have 8-bit registers in 8051. So here R0 is an 8-bit register. So it is moving 12H. This 12H data is moving into a register R0. So after executing this instruction, the R0 register is going to hold the value 12H. Coming to the operands. Apart from the opcode, an instruction also includes objects to act on. The object is called an operand. Here operand is optional. Instructions can be 2, instructions can be 1 or no operands also. For example, if you take this example move, we call it as an opcode or a mnemonic. Now coming to the operands, this is a destination field and this is a source field. I already said that source field can be a data or it can be a memory location address or it can be a register name. But in this example, we have taken it as a data. Whenever I am taking it as a data, the data must be preceded by a hash sign. So this line says that it is going to move the data 12H to the register R0. After executing this instruction, the R0 is going to hold the value 12H. Sometimes even we don't have two operands also. We can have only one operand. Okay, so if say add R1. So here we are taking only R1 as one operand. Okay, sometimes we write NOP. NOP is only an opcode. Or a mnemonic, we don't have operands at all. So based on the instruction, sometimes operands are required as 1 or 2 or none or 3. Depending on the instruction, we write it. So remember that a computer instruction consisting of two fields. One is the opcode field, that is also called as a mnemonic, and the next field we call it as an operand field. Again, the operand field has been divided into two fields. One is the destination field and the second one we call it as a source field. That is very important. Coming to the last one in this particular topic in the introduction, as assembly number representation. So the default numbering system is decimal. Okay, the default numbering system will be a decimal. For example, if you take here move a comma hash 255, it means that the data is represented in decimal form. Okay, and whenever we have a hash here, it represents that it is a data. Okay, and coming to the next one, hexadecimal numbers must be followed by a letter H. Like whenever you write the hexadecimal number here in the source field, it must be followed with a letter H, and it must begin with a number 0 to 9. Here we need to start the hexadecimal numbers with the number, and it has to end with a letter H. So here the number, for example, if I am writing as B2H here, we cannot write B2H here. When you are writing B2H, write it as 0B2H. So it is a hexadecimal number. It must be followed with a number here, and it must follow with the letter H. It has to end with the letter H, and it has to be begin with a number which can be from 0 to 9. And the third instruction we have is all the binary numbers must be followed by letter B. So when you write a binary number here, it has to be followed with the letter B. So these are the assembly number representations we have. Thank you.